So, lesson learned, I guess this thing only records in like 5-minute segments, probably because I'm not paying for the expensive version. So what you didn't see is me continuing to talk to myself for like 15 minutes without realizing that it wasn't recording. The things I do for you guys. Okay, so like I said, I'm going to skip some space on this because I'm going to come in and fill it in later. But we were talking about polarity and how one way to have a charge is to be polar. So I'm going to skip some space. So let's say that molecule number 1 is polar and molecule number 2 is polar. Well, what do we call that force? We call that dipole. Dipole, because thing 1, charge is a dipole, and things 2, charge is a dipole. Okay, so what would be an example of that? What if we had, for example, HCl? Okay, HCl is a polar molecule, and so it has a dipole pulling towards the Cl. Instead of writing the arrow, though, I'm going to draw these little delta negative and delta positive, because hydrogen is less electronegative, chlorine is more electronegative, chlorine's going to get the negative charge on it. All right, so what if I had another one of these? If I had another one of these, then this is a little bit positive, a little bit negative. Well, what does that mean? That means I'm going to have an attraction between this chlorine and this hydrogen, because one's partially negative, one's partially positive. That is a dipole-dipole intermolecular force. All right, so my molecule could be an ion, or it could be polar, or it could be nonpolar. So what if molecule 1 is nonpolar, and molecule 2 is nonpolar? Well, then the name of my intermolecular force is, there's a few names. This is the one I like best because it follows a pattern. Induced dipole, induced dipole. You will also hear this called, probably more commonly, London dispersion. And lastly, you might hear it called van der Waals. Okay, so all of these are names for the intermolecular force attracting two non-polar molecules. London dispersion, again, is the most common, but induced dipole makes follows the pattern for me. So I need some non-polar molecules. Let's say I had a pentane, 5 carbons, with the hydrogens not drawn on them, because we don't do that anymore, and pentane. So I'm going to draw this electron cloud around this pentane, recognizing that this pentane has electrons in it. They can move wherever they want, and every once in a while you might get most of the electrons on one side. Well, if I get most of the electrons on one side, what's that going to do for charges? I'm going to get a little dipole, negative on top, which is going to leave a little positive on the bottom. Okay, just for a moment, this might happen, which means this pentane, which also has, sorry, didn't look good. Not that that looks any better, but this also has electrons. Well, what's going to happen to these electrons when they get butted up against this partial positive? Well, these electrons are going to get attracted up to the top, because negative charged electrons are attracted to that positive end of the molecule. And what's that going to do? That's going to put a little bit of a negative on top, and a little bit of positive on bottom. Now I have a negative and a positive right here. These molecules are now attracted to each other because of their opposite charges. So this molecule doesn't usually have a dipole on it, neither does this one, but there's a dipole here just by chance, which induces a dipole here. So that's called induced dipole, induced dipole. So what's strongest? Ion-ion, dipole-dipole, or induced dipole, induced dipole? Ion-ion is definitely the strongest, and again, if we look back at Coulomb's law, we know that the force of attraction is proportional to the charges. Well, ions have full charges, and they're permanent. Full permanent charges. Compared to dipole-dipole, which has partial charges that are permanent. Okay, and then what would we call an induced dipole, induced dipole? That is a partial charge. But remember, it only happens if the electrons happen to get in the same spot. So we would call that a partial